This is Advanced Algebra Lesson 6-7, the quadratic formula. The quadratic formula gives us solutions to any quadratic equation in standard forms whose coefficients are known. So if we have the quadratic equation ax squared plus bx plus c equal to 0, and we know that a is not equal to 0, then we can use the equation x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. You did look at this quadratic equation in algebra, and you may have even explored it a bit in geometry. We're going to take it a little bit further this year, and we're going to explore it using real numbers and complex numbers as well. So, some things you need to think about when using the quadratic formula. When applying the quadratic formula, equation must equal 0, and your equation must be in standard form. So 0 equals ax squared plus bx plus c. When you do this, you want to identify a, b, and c, and you want to pay attention to their signs. Is it a plus sign or a negative sign? And then we'll explore this a little bit further, but if your discriminant, which is your b squared minus 4ac, if your discriminant is a perfect square, your solution will be rational. We'll talk more about that as we go through some examples. So let's take a look at the first example here. Using the equation h equals a negative 0.00132 x squared plus 0.545 x plus 4 to model the path of a ball, suppose an outfielder makes a shoestring catch and catches the ball when it is 2 feet above the ground. To the nearest feet, how far from home plate was the ball caught? So to begin, we're going to set our equation equal to 0 and identify the ABCs. So our equation originally is going to be, our height was 2 feet above the ground, so it was going to be 2 equals a negative 0.00132 x squared plus 0.545 x plus 4. So now we want to set this equation equal to 0 so we can use our quadratic formula. So we're going to move our 2 over to the other side, which leaves it as 0 equals the negative 0.00132 x squared plus 0.545 x plus 2. And so we can go ahead then and identify our ABCs. So A equals negative 0.00132, B is 0.545, and C is equal to 2. So now I know my quadratic formula is here, the opposite of B plus or minus B squared minus 4 times A times C all over 2A. So I'm going to put my b, but I'm going to make it the opposite. I'm going to leave the plus or minus. Inserting b squared minus 4 times my value for a times c all over 2 times a. So when going through the process, I simplify under my radical and get 0.3076. So I have a negative 0.545 plus or minus the square root of 0.3076. And then when I multiply 2 times this value for a, I get negative 0.00264. And once I solve that on my calculator, I find that x is equal to negative 3.638 or 416.516. Now when we think about this as it pertains to the problem, we're talking about when the outfielder caught the ball and what height that would be, and we know that we can't have a negative height, so we know that the ball was about 416.5 feet from home plate then. Let's take a look at example 2, and we're just going to use some values. Or we're just going to use a simple equation here. So 3x squared minus 10x minus 25 equals 0. So I can go ahead, and my equation's already set equal to 0. So now I can identify my a, b's, and my c's. A is 3, b is negative 10, and c is negative 25. Go ahead and insert your values for a, b, and c. So negative 10 here, 10, or negative 10, and a is 3, and c is negative 25. So that's all over 2 times a. When we take a look at that, the opposite of negative 10 gets me 10. Negative 10 squared is 100 minus 4 times 3 times a negative 25. So that's going to give me 400 under here and 6 in my denominator. So I know that 400 is a perfect square, so that means my values this is going to come out nice and clean, so then I know that I can write this as a fraction. 10 plus the square root of 400 over 6 and 10 minus the square root of 400 over 6 simplifies to x equals 5, or x equals a negative 5/3. So when our value under the radical is a perfect square, we know that our answers are going to come out to be rational values, nice and clean. Okay, we're going to use the quadratic one more time. We're going to look at this explicit formula. T sub n is equal to n times n plus 1 all over 2 for the sequence of triangular numbers. So what they want you to evaluate is 70,876 a triangular number? And if it is, which term of the sequence is it? So when we look at our T sub n equals n times n plus 1 all over 2, we need to take and simplify that a bit, or expand it, I should say. So that's going to give me n squared plus n all over 2. If I move the 2 over to the other side, I get 141,752 equals n squared plus n. And I know in order to use my quadratic formula, I need to have my equation equal to 0. So move the negative 141,752 over to the other side. Now I can use my quadratic formula. My value for a is 1. My b value is 1, and my c value is a negative 141,752. Go ahead and plug things in, and you can calculate that your square root of 1 squared minus 4 times 1 times a negative 141,752 is 753. So when we do that, it comes out with a nice value, and I know if our value is going to be a sequence number, it has to be nice and clean. Has to be an integer, so we get negative 377 or 377. We don't have negative values when we're looking at our sequences, so we know that our 70,876 is a triangular number, and happens to be the 377th triangular number. So this concludes our initial look at the quadratic formula, and it concludes lesson 6-7.